Welcome everyone to Knox Game Design for February 2025. My name is Levi Smith. So this month I'm going to be talking about sockets and how to use sockets in order to make a simple networked game. So what are sockets is a way to allow a game client to be able to connect to a server, a host, be able to send data, be able to receive data from the host for a networked game. So in this demo, basically first I'm going to show how to basically get a simple connection working, and then I'm going to do a demo of a simple number guessing game. So here's a simple connection. So this demo, I'm doing it in Python. Probably isn't the first language that I would choose, but it does make getting sockets working pretty easy. It has it built in as a library. Setting up sockets for other languages such as C# or C++ should be similar. You just need to get the appropriate libraries. So basically this is it right here. I have two scripts, one for the client and then one for the server. So let's look at the server here on the right first. So basically we're importing socket, creating these socket objects. So this is important. We're creating a port right here using 37830. If you are in East Tennessee, you should probably be able to figure out where that comes from. But basically a port, it's just a number. It can be anything you want it to be. I made notes down here. That's going to be your host port number on the server. It's a unique port number for that connection. It can be anything, but there are standards out there for port numbers, such as for HTTP and HTTPS and SMTP and all that. So I would probably advise not to use one of the standard port numbers for your game, but there is a list out here from IANA of a lot of the standard assigned port names, and they keep track of which ones have been assigned. And also be aware that the host will connect back to the client on a different random high port number, so you don't get to choose that. So that's basically what this is. Setting the port, going to bind using that socket to that port, listen, the server's going to set, socket's going to be set to accept, and just a print statement saying the socket's running using that address. Then we're going to have one while loop right here. You're just going to listen for data coming in, and when it receives, that's 1024 bytes of data, and basically like a packet of data. We're going to say the server received that data, and then we're going to wait for input for the server to send back to the client. We're going to say server send right there. Then we're going to send that right there. So basically server send right here is just the command line, what's going to be displayed on command line. So it's going to send back whatever you enter on the command line back to the client. And then if you send quit, then it's going to break out of that loop and close the program. So that's one part of it. The other part is the client over here, the client script. So it's really simple. We're going to import the same socket library. We're going to create this socket object. We're going to connect on port on IP 127.0.0.1 on that 37830 port. So 127.0.0.1, which many people probably know, that's going to be the local host. So I'm not actually going to do this over the network or anything. This is all going to be local host for this demo, but you could take this and put it on a real server and it should work okay. So we're going to have another while loop, infinite loop right here. And so while true, we're going to read a line of input from the client, and then we're going to send that up to the server, going to encode it. And then if we send quit, then we're going to break. And then we're going to, if we receive data back, we're going to print client receive, s.receive, that 1024 bytes of data right there. So pretty simple right there. I'm going to show you this. So I got this working. This is going to be under Windows using MSys2, which I've used in the past. Kind of like a simple Unix style shell that you can use. So what I've been doing is I'll have the client, I guess because I worked on the server first. So got the server over here, VI into server.py. This is the code that I just went over, the server code. Then over here, I'm going to do VI client. Here's the client code in the right window. Exit out of these. It's kind of important with this simple script to run the server first. So we're going to do python.server.py. So it doesn't say anything when you start it up. Python client.py. Okay, so right when I started the client, you may have noticed over here on the server it said socket running. So it made that connection. And here's that high port I was talking about. It's that random number you don't get to choose, 54358. So the client connected to the server, which is all localhost on 37830. Then the host connected back to the client on 54358. So on client, we're going to send hello. And you pay attention, you're going to see the server received hello. And on server side, you can send back world. And the client received that world message. So that's the basics of it. Very simple. Type quit there. Type quit there. That's what I have on this slide right here. Start the server first. A separate window, start the client. Enter hello on the client, sends that to the server. In a world on the server, client receives a world. So pretty simple stuff. Basically what I went over, but I just want to put it in a slide just for reference. Okay, so this is one interesting thing here. I should have left it running. But once you have that connection working, you can run a command netstat -a. Pretty standard command right here. Netstat -a. I think it's the same thing under Linux and Unix as well. But if you go into your Windows command line, CMD, you just type netstat -a, and you can actually see the connections. Let's do that real quick. Just gonna run CMD. Of course, you have to have the demo running, or I won't see those. So let's go back to our MSys2, start our server, start our client. Just going to send hello again. See that? So now, if we go back to our Windows command prompt right here, we're going to do netstat -a. It's going to bring up all the ports that are listening and established. And if you go back up right here, you see it's a TCP. One thing you got to be aware of, there's two types of connections, TCP and UDP. TCP does like checking, make sure the packets are received and in order, correct order. The other one is UDP, which I'm not going to be doing in this example, but UDP doesn't guarantee that the packets are received. UDP is better for things that where you receive like streaming data, where if you don't receive a packet, it's not important. But for like a game or turn-based game where you're expecting data to come in, it's probably better to use TCP. So you can see right here, 37830. This is right there, local address. So this is the host is listening on 37830 right here. And then if you go down here, what's interesting, you can see TCP 5447 on my computer's called Octorock on the local host foreign address. 37830 has an established connection. That's basically what these two are doing right here. So if this was a true networked game where the server was on a different server, you would only see the client connecting. You'd only see one of these. You'd only see the client connecting out. You'd only see this one right here, the established. And then if you went on the server, you'd see 37830 listening up here on the server. But since I'm not doing two separate servers, two separate systems, they're both on this one screen right here. So yeah, that's pretty cool. It shows, hey, we sent a packet, received the packet. That's basically what this screen is showing right here. So that's the basics of a networked game. If you want to get into doing multiplayer stuff like that, this is kind of the basics. So that's a nice test, but what if we want to do a simple game? My game that I always say everybody should start out with is the number guessing game. So here's a local number guessing game command line right here. So in Python. So you could actually use this and like do Pygame and make a GUI interface for all this and everything if you wanted to. But we're importing random, will give us the random number library. Got a min number of 1, maximum of 100 for the range of the numbers that can be guessed. So the secret number is going to be random range minimum to maximum plus 1. Current guess, we're just going to set it to -1 for now. Guess count, initialize that to 0. While the guess is not the secret number, we're going to read the input, convert it to an int, assign that to our guess, increment the guess count. If the guess is less than the secret number, we're going to return higher. If the guess is greater than the secret number, we're going to return lower. Then if the guess equals the secret number, we're going to say correct. Print out the guess number of guesses, the guess count, and say total guesses. Then when it comes around to this loop again, and it's going to fall out right here. I guess you could have put a break down here, but right here it'll come up and say, hey, the guess matches the secret number, and then we'll fall out of that loop in the game. So in this direction, I'll have all this code up in an online source code repository. So I got numGuess not networked py. That's our non-networked number guessing game. So we're going to do Python numGuess not networked. So it doesn't even give a prompt. Made this pretty simple. So I'm going to guess 50 lower, 25 higher, say 32 higher, 40 lower, 35, 37, 36. Okay, so I guessed it in 7 guesses. So that's our basic number guessing game in Python. So why did I go through that? Well, you kind of need to know what you want your game to do before you make it networked. So here's the new and improved networked version of our number guessing game. So we're going to basically start out with the same skeleton code for our server and client scripts. And it'd probably be better to like put these in separate files and take it out of the game logic. But since this is just a demo showing how sockets work, I just got it all in here. So I just basically added the minimum number, maximum number, 1 and 10. This is the same exact code in our non-network version. There's our socket. Same thing going on here. If we receive a quit, we're going to break. So basically the only change is like our guess is going to be the int value, kind of like casting as an int, or I to A to I of our received data, the data that the server has received from the client. So the server is going to have generate the secret number, random secret number, and keep track of the guesses. All the client is going to do is let the player enter numbers and then send that to the server as guesses. And then when the server's going to reply for each guess, whether it's higher, lower, or correct. It's matched. And once it's matched, say how many the total number of guesses are. So we get assigned the received data into the guess variable, increment the count by 1. Same thing we did in the non-network version. So here's our same if statement, if, else if. If guess is less than secret number, the data we're going to send back higher. If the guess is greater than secret number, we're going to send back lower. If the guess number equals the secret number, you could just do an else right here because that's the only other thing it could be. But just for readability, I guess, the guess number equals secret number, we're going to send correct number of guess count, total guesses, send that back to the client. So here's our client right here, importing socket. Same thing as with the test connection. So basically, the only difference is we're getting the input string. Actually, it's pretty much the same exact thing. And then we're going to receive that feedback. I really don't even think there's a change in the client because all the client's doing is sending guess numbers up to up to the host. So that's what it looks like right here. Now I'll go ahead and show you the demo for MSys2. And yeah, this should also work under Linux, Ubuntu, which kind of one of the reasons I picked Python is because Ubuntu now, I believe, comes with Python installed by default. So if you just want to get this up and running real quick, and maybe even Red Hat or Fedora too. So this is demo 02. Want to make sure we start the server first. Server.py. Not going to say anything until the client connects. So Python client.py. And just to prove, it's listening on 54779 right there. So if we go back to our net stat over here, I'm going to go ahead and do another net stat -a. Just to prove, got our server right here, 37830. It's listening. Then on here, 37830. Here's the client with the connection established. 37830 on 54779. And that's what that says right here, 54779. So from the client, I'm going to send 50, since 50 is halfway between 1 and 100. Higher, let's say 75. Higher, 82. Higher, go ahead and go up to 90. Lower, say 85. Higher, 87. Correct, 6 total guesses. And then you see over here popping up on the host side, here's the values that the server received. I could have put some debug information in there just to say, hey, but maybe print out what the secret number is. But yeah, that's basically a networked game. If you want to do networking, multiplayer games, that's basically the foundation of it right there. Like I said, there's also libraries for doing it in C#, Visual Studio for Unity. I looked into that just a little bit, and it just seemed like the Python was just so much easier getting the socket set up. But there's a way to do that in C# for any of your Unity games or whatever other libraries you may use, or Monogame, things like that. Yeah, so if you're actually running the server on a remote host, you got your own server, then make sure you're allowing the client to connect through any firewalls or routers. Make sure that port's open, because a lot of systems will block that by default. If it's not working, you need to check into that. If you're running the server from your local host, you need to make sure port forwarding is set up to allow connections from remote clients through any routers or anything like that. So that's one hang up, and that's why I just did the example on the local host, just to make it simple. That might be a talk for another day, opening up things like that to be able to communicate with remote servers. So anyway, that's just going to be a quick talk on sockets, basics of sockets. Get people started with networking games, so hopefully everybody found it useful and informational. So appreciate everybody out there listening and watching, and I'll plan on being back in a month.